So I just heard a little message that says recording in progress. So we should be all set there. Thank you all for joining us for our October Superstellar Friday. My name is Mirka Zaplatal, and I'm the Director of Education at the McAuliffe-Shepard Discovery Center. And I am very excited to have Tom Mortimer with us tonight. Tom is so generous in his time and his knowledge for us at the Discovery Center. For any of you who have come to visit, when you find the Minerals of New Hampshire display and the interactive touchscreen as well, that's all him. And to be honest, that's also me regularly saying to him, something's gone wrong in the program and I don't know what I'm doing. Can you help me? And then he fixes it and it works again. So we really appreciate all of the effort and energy that he puts into our visitors' experiences with that. And so I don't know why it didn't occur to me sooner to ask him if he would do a talk on New Hampshire minerals, but I'm really excited that he agreed and that we could find a day that worked for this. So just as a reminder for those of you who have been to these before, and as some information for those of you who are new to this, I'm going to turn it over to Tom shortly, and he will do his presentation. The chat will be open the whole time, so if you have a question or a comment, you can put it in the chat. I also have enabled the Q&A, the question and answer option, where you can do, basically it's the same thing. You can put in your question, but it's set up so that if you put in a question, everyone else can see the question. And if they have the same question, they can like it, essentially. They can vote for it to say, yes, this is a really interesting question for me too. And it just kind of can help push a question to be answered sooner because a bunch of people have the same question. So you're welcome to use either of those venues, or just hold on to your question at the end and we'll unmute you and you can ask it verbally if that's your preferred style. As I said, I'm recording this. We are recording this to the cloud and we'll make the link available, but your video is not being recorded. Your audio is not being recorded unless you choose to ask your question or make your comment verbally at the end. So with that, Tom, I'm going to turn this over to you. I'm going to mute myself and stop my video, and I'm all excited to learn about New Hampshire minerals.
Okay, we'll start in the share screen. Share. Okay, can everybody see this? I don't know. I guess we'll assume people can.
Yep, I can definitely see it.
Okay, great. Okay, I know I've reviewed some of the past Stellar Friday talks, and I've seen that most of the topics come from cosmic distances that are very far from New Hampshire. Tonight, I'm going to talk about something that's a little bit closer to home. And that my topic is the minerals found in New Hampshire, collecting these minerals and the collecting hobby. So let's get started here. And if I can advance my slide, I'll really be doing well. Push this button, that button, this button. How do I advance the slide? Oh, here we go. I did some magic. I thought I'd start off with just a few photos of some mineral specimens from my hobby that I have found in New Hampshire to kind of perk up some interest at the beginning here before I get into some of the details of the different mineral environments and how to collect them. This is about a 5-inch specimen of the mineral dolomite. This came from Westmoreland, New Hampshire. And here we have a somewhat smaller, maybe 2-inch specimen of a bright blue azurite. This one is from Westmoreland, New Hampshire. And this specimen here is probably only a few millimeters high, and these rather bright blue crystals. And these are from the Mascot Mine in Gorham, New Hampshire. Continuing along here, we have these cluster of rather striking milky colored spheres in a small cavity. And the field of view here is probably only about 4 or 5 millimeters across. And this is the mineral aragonite, and it came from Raymond, New Hampshire. And here we have a quite nice green, intense green crystal spray of the mineral malachite. This one also came from Westmoreland, New Hampshire. And in this shot, probably about a 3-inch specimen of this lustrous blue blade crystal. And it's embedded in a kind of a milky, rusty quartz. And the mineral here is kyanite, and that came from Lyme, New Hampshire. And here we have a rather bright purple or lavender colored mineral embedded in another rock type. And this is the mineral heterosite. And this specimen came from the Chickering mine in Walpole, New Hampshire. And of course, you got to show a gold specimen because everybody's probably going to ask about this at some point in the talk. It's not particularly big. It's about 1/2, 3/4 of an inch across. It's a nugget. And this one was panned from the Wild Ammonoosuc River in Swiftwater, New Hampshire. So yes, gold really can be found and collected in New Hampshire. And it's a fun thing to do, gold panning with the family, particularly in August and maybe up through September when the river water is not going to turn your ankles numb within the first 10 minutes. And here's another precious metal mineral here. This is a maybe about a 2 to 3 millimeter curlicue of wire silver, kind of a striking example of that species. And this one also came from that Mascot mine in Gorham, New Hampshire. So now, starting with a little bit of review on rocks and minerals. Probably most learned at some point in their education that a rock is a mass combination of 2 or more minerals. An example is granite. Of course, we are the granite state, and we know that granite is a combination of usually the 3 minerals: quartz, mica, and feldspar. On the other hand, a mineral is a crystalline solid, and I should say that the mineral has a rather specific definition. It has to satisfy all these criteria in order to be called a mineral. So a mineral is a crystalline solid. It has to be naturally occurring, which means man-made things don't qualify. It has to be inorganic, and so from that sense, coal doesn't qualify, even though it's certainly very hard. And it must have a definite chemical composition, and it must have definite characteristic physical properties. And these might be such things as hardness, luster, color, solubility. And there's a moderate list of what these different physical characteristic properties might be. And an example of a mineral would be quartz, which is silicon dioxide, a combination of the mineral silicon and oxygen in a ratio of 1 to 2. Mineral species worldwide, the list keeps growing. Mineralogists love to find new things, and the tools to study mineralogy are getting more and more sophisticated, and particularly the more younger mineralogists love the idea of maybe getting a mineral named after themselves. So there's a lot of study going on. Presently, there are over 5,000 different distinct mineral species worldwide. In New Hampshire, we have a pretty good representation from this 5,000 plus set, but still only about 330 distinct mineral species have been identified from New Hampshire. But still, compared with other states, that's a pretty respectable tally. I maintain on my website, min-nh.org, what I believe is the current confirmed list of New Hampshire minerals. And these are alphabetically listed here. As I continue with my talk, at this point, I think it's important to gain an appreciation for the size range of some of the mineral photos that I will show. On the left edge, we have a U.S. quarter, which is about 1 inch in diameter. In the center, a rice grain, about 7 millimeters. And we have salt cubes on the right here at about 0.3 of a millimeter. And some of the minerals that I am going to show photos of to follow will span this whole range. So kind of keep these sizes in mind as you see some of the crystals, especially the small ones. And I might also sort of note that mineralogists use the metric system for specimen measurement. So the specimen sizes that I will reference in slides to follow will have metric dimensions on them. An example of a really large specimen from New Hampshire is this dinner plate size specimen of the mineral microcline. And these sharp tan-colored crystals came from the Lovejoy quarry in Conway, New Hampshire. In terms of full disclosure, these were collected probably about 40 or 50 years ago. So old specimens continue to get recycled into new collections. At the other end of the extreme, this colorful orange crystal here is only about 3 to 4/10 of a millimeter across. Now, recall those little salt cubes that I showed the photo of before. So this is this small anatase crystal, which is a titanium dioxide mineral. This came from the Audley quarry in Merrimack. And I guess one comment I might make is that when these crystals are very small, they have a less chance of bumping into as they grow or growing into something else. So when they're smaller, Mother Nature gets a less of a chance to kind of goof it up. So they tend to be frequently more perfect. So now I'm going to go into the topic of New Hampshire mineral environments. New Hampshire has a number of different rock types where minerals are formed, and a mineral environment is a body of rocks that have formed under a common set of conditions. And knowing what the mineral environment is, if you're out in the field collecting, can be a great aid in helping you to find and identify minerals. If you know the environment, that can help you perhaps easily discard a bunch of other similar looking possibilities because you know that particular mineral is quite unlikely to have formed in the environment you're collecting. But you still have to come to sort of recognize, well, what kind of mineral environment am I field collecting in? The first of these I want to talk about is the pegmatite. And a pegmatite is a coarse-grained igneous rock body that usually forms as dikes and sills, intruding into granite or other metamorphic country rock in New Hampshire. And there are many old pegmatite mines in New Hampshire. These mines were quite active from earliest starting about the mid-1800s up through the mid-1900s. And the principal minerals that were mined in these quarries was mica and also for feldspar. And particularly during the World War II, mica was a strategic mineral in that it was critical to the war effort for such things as insulator material. And the insulators in a lot of vacuum tubes at the time were made from mica, as well as in electronic components such as capacitors. And because it was a strategic mineral, the U.S. government put a very high price support on mica, and that incentivized a lot of mica mining in New Hampshire and actually throughout New England. I would, I guess, finally say about pegmatites is that it is an excellent target locality for the amateur hobbyist collector, as that environment usually has a quite diverse group of minerals that it hosts. This is a rather crude example of a pegmatite. This one is a sill. It's over next to Home Depot in Merrimack, New Hampshire. And this, what you see here is the dark rock, is the country rock. But then you can see this sill here of quartz and feldspar. And I like this shot because it really does show the intrusive nature of this pegmatite emplacement. And it's, you know, what, about 5 or 6 feet across and runs 40, 50 feet with a kind of a gentle down slope. And if you look at such a pegmatite such as this, sometimes you will find specific minerals embedded in it. Here in this particular view of this pegmatite, you can see some black mica or biotite mica that is formed within this chunk of feldspar. It's probably about a foot-long field of view here. Now, here's an example of one of the more famous pegmatite mines in New Hampshire. This is the Palermo mine in Groton, New Hampshire, and it's particularly notable because it is the most mineral species prolific locality in the state, with over 200 different species have been found and identified from this locality. And this, I would say that this particular mine is under the ownership of a group of 5 or 6 mineral collectors who are actively working this pegmatite for mineral specimen recovery. It started off its life as a mica mine, and also was a substantial feldspar mineral producer, as well as the mineral beryl or beryllium, which was also during World War II another designated strategic mineral. Some of you may recognize this mine. This is the Ruggles mine in Grafton, New Hampshire, an absolutely cavernous, huge pegmatite mine. This was operated for a few decades as a tourist attraction. Perhaps some in the audience here have actually visited this locality. It was closed to the public about 2 years ago or 3 years ago. And it has been subsequently purchased by a gentleman from New York who has at least a design to reopen it as a tourist attraction. Unfortunately, at this particular time, it is not open. I certainly have great hopes that it will reopen as a destination for amateur collectors. Here's another example of a pegmatite occurrence. This is the Parker Mountain Mine in Stratford, New Hampshire. And you can this is kind of typical of a pegmatite mine. A lot of people may think of mines as requiring a tunnel or an adit or some kind of cavernous thing inside of country rock. Very few of the New Hampshire pegmatite mines are actually tunnel mines. Most all the mica mines were operated as basically open pit mines, or perhaps such as this one, kind of tunneling in to some extent into the country rock. Again, you can see the limits of the pegmatite are kind of around here, and it's the kind of pegmatite is usually a pretty well-defined zoned igneous body, and usually has multiple different zones in its formation, from the wall rock zone to the inner core zone. And learning and knowledge of what these different pegmatite zones are can be helpful to the collector in where to collect, and perhaps even helping to identify what particular mineral he may have found. Here's kind of an extreme example on a kind of a poorly presented pegmatite mine. This is the Chickering mine over in Walpole, New Hampshire. This is actually part of a Boy Scout multi-acre camping reservation. And the kind of the back wall of the pegmatite is in the center portion of this photo, and in the foreground is what remains of the former mine dump. Perhaps a word on the mine dump at this point. Most of these pegmatite mines, all of them, had rather large dump piles of waste rock that was of no value to the mining operation at the time they were mining. But these piles of waste rock are excellent targets for the hobbyist collector, because oftentimes they contain more interesting minerals, and they're all kind of broken up and crushed up into nice fist-sized pieces frequently. And you can sort through and dig into these mine dumps and find some interesting specimens, many of which I will show in slides to follow. It's an example of mineral collecting at a mine in Orange, New Hampshire, many years ago for me. This is 1991, collecting with my youngest son at the time. And mineral collecting is a great hobby to engage the whole family with. And I think aging adults will find that there are kids who, with probably better eyesight and closer to the ground than many of us, can spot things that adults frequently miss. It's kind of an example of what a pegmatite rock looks like. A little overexposed here, but the lower portion of this pegmatite rock is kind of a gray quartz, and the upper portion is a white feldspar. This is another example of a pegmatite rock. This one kind of illustrates some of the zoning you may see in a pegmatite. You can see the lower zone here, which are probably closer to the wall of the pegmatite, and a rather well-defined lineation horizontally here, transitioning into the next zone, which is mostly a feldspar composition. And interesting, why I lugged this 4 miles out from this mine deep in the woods, is up on top here is this complete double terminated greenish yellow beryl crystal, a beryllium silicate mineral, which is a popular mineral for hobbyist collectors. Beryl, of course, is the gem name of beryl. Well, one of several is aquamarine, and aquamarine is a mineral which lapidarists frequently cut into a nice gem stock. This beryl crystal came from over in Goffstown, New Hampshire, and it was just a pegmatite outcrop in the woods. And I had a friend from another section of this crystal facet me this nice gemstone from, I don't know, about 3 carats for my wife. My wife has to get some enjoyment out of my hobby. There's another pegmatite mineral. This is the black tourmaline variety dravite. And it's, I guess, a 4-centimeter specimen here. It's a cluster of these lustrous black crystals here, a member of the tourmaline group. This came from Alstead, New Hampshire. When tourmaline has kind of bright colors, it can be darker green, light green, blue, and pink and purple. And when it's in those states and nice glassy, it is a very sought after gemstone for the jewelry industry. This is the mineral elbaite, which is a lithium sodium variety of of the tourmalines group. And there are a couple fractured crystals here embedded in a feldspar quartz matrix. This one came from the Chickering mine in Walpole. Here we have a crystal apatite. Actually, apatite is a mineral group name. This is the fluorine-rich version called fluorapatite. It's about a 1 centimeter crystal, and it occurs in a vug or a small cavity of Clevelandite feldspar. Let's talk about the next mineral environment, which is ore veins or hydrothermal veins. These are not as common as the pegmatite environment in New Hampshire, but still we have several good representations in our state of this mineral environment. And by hydrothermal, I mean it's a mineral deposited in a hot water-rich solution, which basically usually a crack or a fissure has formed in the country rock, and through hot solutions deep within the earth, the water, the mineral-rich water, as it rose up towards the surface, cooled, and the minerals contained in the solution were deposited out on the walls of the fracture, and most frequently totally filling the void. And most economically important is that these hydrothermally deposited in veins are enriched with metallic ores, probably principally ores of lead and zinc are probably the most common ones you would find in New Hampshire. And there are, as I say, there are dozens of old metallic ore mines in New Hampshire, and we'll talk about a couple of those. This is what remains of the Madison lead mine in Madison, New Hampshire. And this is a very easily accessed old mine site. It's on public land. The green water pit here is a water-filled hole that was excavated by the mining operation, but there are moderate-sized dumps on either side of this excavation, which are a good source for searching for minerals. And it's kind of a zero hike locality. It's probably only about 15 or 20 yards from a well-traveled dirt road, so easy access, a place some people like to start when exploring this. This is an old photograph view of the Madison lead mine in, I'm sorry, the Mascot mine, get that right, in Gorham, New Hampshire. And this was a long active lead and zinc deposit mine. It's maybe only a few hundred yards off the Appalachian Trail, and this photo here shows the mine as it existed, probably at about the peak of its mining operation. This was a true mining tunneling operation with shafts and adits, and they had housing close by for the miners. It was a profitable active mine for many years. But today it's a good destination, particularly for a micro mineral collector. It's a black and white photo of that same mine, showing the living quarters for some of the miners, and the mine is kind of up in the right central part of the view here. And this is an example of an ore vein rock, and this did come from the Mascot mine. And what we have here in the inner core, we've got a kind of a cream-colored siderite crystal, which is altered quite heavily. Siderite is an iron carbonate mineral, and it's surrounded by a rind here of galena, which is lead sulfide, and sphalerite, zinc sulfide. It's also a little bit of quartz over here as well. But this is typical of an ore vein rock sample. Also in the category of hydrothermal veins are the fluorite veins from New Hampshire. And these are to be found principally over in the western part of the state, most notably in the town of Westmoreland. And fluorite, particularly from that locality, forms these rather nice frosty green octahedrons, frequently on matrix, such as this specimen here, and was a very popular mineral for collectors. This wise mine was operated for specimens quite actively about 20 years ago, and they extracted a lot of fine specimens from that vein over several years. At the present, this property is in private hands and unfortunately off limits to collecting currently. Now we're back in the micro domain here. This is a 1 millimeter wolfenite crystal. This came from the Mineral Hill locality in Wakefield, New Hampshire. And it's a nice, attractive tabular mineral with some secondary face developments on the edges. It's a lead molybdenum mineral. Another lead ore vein, lead mineral, metallic ore vein mineral. Here, this one is the mineral pyromorphite. Another small specimen, about a 1 millimeter crystal, but as I kind of referenced earlier, that more often than not, when they're small, they tend to be a bit more perfect. I'm going to talk about the next mineral environment here is myrolithic cavities. And these are cavities that formed in granitic rock. Probably a lot of them formed as a result of during the igneous formation. There were some gas bubbles in the melt that resulted in voids, which allowed distinct crystals to form. This is my son's many years ago attacking some myrolithic cavities on a mountain in Ossipee, New Hampshire. So a fun place to collect. And here's an example of kind of the extreme of a myrolithic cavity. This one is in Albany, New Hampshire, way up in the woods. One of these spots you really got to know where it is. You're never going to find it. It doesn't look like much. It looks like a kind of like a manhole here, but you can, and it's pretty much water filled right now, but you could pump it out. And at the time it was collected, you could easily stand up inside the big cavity that this hole opened up into. And from this particular myrolithic cavity, there were just hundreds and hundreds of pounds of nice smoky quartz and microcline feldspar crystals were found by the collector. This is an example of a myrolithic cavity specimen, kind of typical. This one's from the government pit in Albany, New Hampshire, which was a very excellent place to collect about 30 years ago. Unfortunately, this pit was used by the Forest Service and for provide gravel and road metal for a lot of their roads in the area. And they did expose a lot of ledges which were rich in these myrolithic cavities. The minerals which are present here you have these smoky quartz crystals, the dark quartz crystals here, and these slightly greenish feldspar crystals. I'll point out a feature of a myrolithic cavity environment here is along the border here, along the bottom, you can see the granite is quite fine grained, but as you approach closer and closer to the actual cavity itself and where the distinct euhedral crystals form, the grain of the granite gets a lot coarser. And that is in part due to the fact that the inside of the cavity cooled relatively slowly, and the slower cooling allowed the crystals to form more completely. Here's a close-up view of a merolithic cavity specimen. In the center is a kind of a pale green microcline feldspar. The green variety of this feldspar is referred to as Amazonite for its green color, but also we have a number of smoky quartz crystals on the perimeter of it as well. This is what a nice specimen of a smoky quartz crystal would look like. This is about 1.5 inches high with some associated feldspar on the left side. A very sought after species that does occur in merolithic cavities is the mineral topaz, and some very nice topaz crystals have been found in New Hampshire. It's a great find when you make it, but they are at a quality and size such as this one are quite rare. And there are a number of quite tiny minerals to be found in these merolithic cavities, but again, these are usually quite pretty. This is a micro-like crystal, about a 1 millimeter across, in a small feldspar vug. Another species to be found in these cavities is the mineral phenakite. It's a beryllium mineral. It's about 3 centimeter tall crystal. Okay, moving on to yet the next mineral environment that you can encounter in New Hampshire is the metamorphic mineral environment. And by that, a metamorphic environment is where rocks have been reformed under great pressure and temperature, usually quite deep within the Earth's from the Earth's surface, and we have our multiple glacier events that have planed off thousands of feet of bedrock across New Hampshire to expose some of these previously very deeply buried metamorphic minerals and metamorphic environment, and exposing some of the minerals that can be found in this environment to the collector. An example here is a metamorphic rock which is kind of peppered with a half dozen iron garnets, almandine garnets. The garnets are quite common in New Hampshire, not one of the more easily found and identified species. It's another garnet crystal here. This one more from Sugar Hill up by Franconia, and about a centimeter across crystal. Garnets typically form in this habit, and this habit is a 12-sided figure called a dodecahedron. Another popular mineral to collect in the metamorphic environment is staurolite. This one from Lisbon. It's about a centimeter crystal. These are typically diamond cross-section blades that are embedded in a metamorphic schist typically, and frequently accompanied by the garnet species. And you can see several garnets in this view as well. Also, less common in that environment, and usually in fractures, quartz-filled fractures in that environment, is the mineral epidote. This example here, about 4 centimeters high, is from Winchester, New Hampshire. Excuse me. A rather uncommon mineral environment in New Hampshire is the skarn mineral environment, and it's basically a metamorphosed limestone that started off as the parent rock, and which is a calcium carbonate based, calc silicate based environment. This is a typical chunk of a skarn rock. And that's about all this is pretty much just a rock sample. But of interesting to note, you can see the layers of green and kind of red alternating here, and interspersed with a little bit of white. Now the red is the calcium garnet, grossular, and the green bands are principally the mineral diopside, and the white is calcite. And so this would be a typical example of a skarn rock. But in the skarn environment are some nice mineral specimens to be found. This is a kind of a co-joined pair of grossular garnets, about 3 centimeters high, so it's a bit over an inch high. Again, they're having the kind of the classic dodecahedron habit of the garnet family. Here's another example, also from Amherst, the Joppa skarn. And in the rear here, we have one of these grossular garnets, and on the front forward facing is another common mineral species in the skarn environment, which is the mineral Vesuvianite. And you can sort of guess where that was first found. Here's another nice skarn mineral specimen example, a nice plate of kind of red-orange grossular garnet crystals, a little bit of white calcite interspersed in the deeper parts of the cavity. And the reason that these crystals survived as nicely as they did is that they were, when they were in the ground many eons ago, they were covered by a layer of calcite, which really is a calcium carbonate, which really protected the crystals from further deterioration. And when a collector finds a specimen like this, perhaps with a few of these grossular crystals poking through, what you want to do is stick it in a tub of vinegar in a nice warm spot for about a week. And of course, vinegar being a mild acid will actually eat away the calcite, the calcium carbonate, and leave you with these nice undamaged grossular crystals. Takes some patience, but the result is quite rewarding. Your specimen may smell a bit of vinegar, sort of like a salad after a few weeks, but it's a small price to pay. Now I'd like to kind of get away from the mineral environments topic and talk about the mineral collecting hobby and sort of the where, the how, and what tools to use. Start off with some references, and there are a couple of really pretty good ones. One is the just recently published Rockhounding New England by my friend Peter Christophano. This is available directly from Peter and the web link there, but Amazon and some of the local bookstores also carry this. And it is a guide to 100 of the region's best rockhounding sites. So it's not just New Hampshire. There's probably 20 or so in New Hampshire, but this spans all 5 New England states. And a nice feature of this book is it does provide detailed directions. And these are sites which are, at least at the time of publication, were open to the mineral collecting community. Although some of them are open only by basis of entering the property as a member of a field collecting group, such as a mineral club. And the book is also well illustrated with many color photos of the different specimens that you may expect to find at these localities. Probably the little booklet that got me most involved and really into New Hampshire mineral collecting back 45 years ago was this little blue booklet in the lower photo here, New Hampshire Mines and Mineral Localities by Philip Morrow. I think it was probably first published in '58. This is the 1960 edition. It has since been reprinted by 3 or 4 other printers. You can obtain a copy through the, I think the Gilsum, New Hampshire Public Library has copies for sale. And, but it is also available in its complete entirety online at the New Hampshire Department of Environmental Services website, NHDES. So it is a freely available publication, but it has town by town listings of probably about 500 mines and mineral localities within the state of New Hampshire, and with for most of them directions on how they may be found, and a list of different mineral species that one may expect to find at that site. I also would recommend for a beginning hobbyist mineral collector, acquisition of a good rocks and minerals identification book. This Peterson Field Guide, which is basically a reprint of the original Fred Poe Rocks and Minerals book, which is another one of my early Bibles, is a good purchase. It's available in paperback for a nominal amount. We also have a number of web references today, which have made perhaps some of these mineral identifier books a bit obsolete. I have now an opportunity to plug my own personal website, which is New Hampshire Mineral Species website, which is mindatnh.org, right across the bottom here. And that's where you will find that mineral species list that I put up earlier. And on my website, I have photos of now about 3,000 different mineral specimens from New Hampshire, spanning about 330 distinct mineral species. So I'd like to think this is a good reference for the hobbyist collector. And there's also, I have about a dozen locality web page sets, which if you are visiting one of those specific collecting localities, you can kind of preview to see what has been found there and maybe help you identify some of the things you bring back. The probably the absolute best world-class website is mindat.org, and they presently have photos of something in excess of 1 million mineral photos. And it's also would be a resource if you want to look up a lot of the physical properties, optical properties, crystallographic properties of minerals. Just a very exhaustive website. It's kind of neat. Every day there's about 100 new photos submitted worldwide from collectors and some mineral dealers of what is being found of late, or maybe what's being recycled from old collections. And finally, I would mention there's another mineralogy database, webmineral.com, which you can use. There's not a lot of photos on it, but a good reference for physical property data, optical data for different minerals. Of course, so for the starting mineral collector, probably one of the best resources is to join a mineral club, a mineral hobbyist club. And in New Hampshire, we have at least 6 of these. I've enumerated them here. We have the Capital Mineral Club in Concord, probably one of the most active and largest clubs. The club over in Keene, the Presidential Club up in Gorham, Saco Valley Club, the Southeastern New Hampshire Club, and finally the Microminers of New England. Now, the Microminers, which I'm particularly involved with, is particularly focused on micro-sized millimeters. These would be millimeter or so size minerals that are best viewed with the aid of a stereo microscope. And being somewhat of an esoteric part of the hobby, we have to cast a sort of a New England-wide net in order to get a quorum of interested collectors in that particular part of the hobby. An advantage of belonging to a mineral club, of course, is the monthly newsletter, and most of these clubs publish these newsletters, and they are usually have details on upcoming field trips and articles on things that mineral collectors have recently found on field trips and from their personal collections. So, and one advantage of joining a mineral club. Another one is particularly valuable is mineral clubs sponsor field trips. And mineral clubs, through their insurance that they hold, can gain access to active mineral quarries that are otherwise closed to private collectors or private individuals on a personal visit basis. And so this is a great activity because you get frequently to go with other collectors who are experienced and can kind of help you on the spot as to identifying a nice crystal as opposed to a piece of leverite, and also maybe point out areas where maybe it's most profitable to expend your energy collecting. It's another example, this one of the Palermo mine, a field trip that was sponsored to that spot. And it's kind of interesting to note here, the field trip sponsors actually put some little signs out in the different spots you can see in the quarry here to alert the collectors as to, look here for this. So there are some good helpful aids with for the collector there. A few words on collecting tools. This is part of my collecting kit. You probably want to have a bucket to bring your material home with. A shovel is of some sort is recommended. A hand sledge, a rock hammer, a couple of chisels, a ballpoint, wedge chisels, a broom. Gloves are certainly recommended. You can slice sharp. Quartz, when it's broken, is very sharp. You can slice up your fingers pretty quick if you don't have your hands protected. Knee pads are good for having a pair of jeans last for more than one trip. Some newspaper to wrap your great finds in. A lot of the quarries, the active quarries that do allow field trips do require safety equipment such as a hard hat, a fluorescent vest, and usually some steel-toed shoes. Again, if you're going on a mineral club sponsored field trip, they will alert you ahead of time as to specifically what kind of safety equipment is maybe either absolutely required or recommended. In the back here is kind of like a 4-pronged cultivator tool. Such as a tool like this is very useful for kind of powering through dump material and pulling out a lot of rock and looking it over in a quick fashion. And then some heavier collecting tools depending on the where your collecting target is. One of my favorites is this Maddox tool here, a heavier, I think that's about a 6-pound sledge. It's a Walmart fiberglass handleless sledge that's cut about 1.5 feet off the handle, and a 4-pound hand sledge. So, and if you're going to pack a long distance or expect to walk more than a mile or more into the woods, you probably don't want to just carry a bucket. So a good backpack frame is probably what you might want to consider. And a final word here is finding a good specimen can be a lot of work. A lot of these localities, the old pegmatite mines, have been moderately collected over the years, and frequently a moderate amount of effort is required to dig down into some virgin material of the dump to expose some some of the dump area that hasn't been sorted through by a previous visitor. Another excellent source of mineral specimens, this one's probably the easiest acquisition method, but can be expensive, is attendance at a mineral and gem show. This shot here is from the recent August 2021 Capital Mineral Club show. This is the Concord Club show that was held in the Concord Arena. And at this show, there are close to a couple of dozen dealers who are selling mineral specimens at all price ranges from dollars up to, it's not uncommon to see five-figure prices on some particularly attractive exotic specimens, but that's uncommon. It's a good price just to come and look at the eye candy. These shows always have multiple tables of mineral displays, which are put in by local collectors, and you can see what the local community is collecting. These are gem shows as well, so there are also dealers in jewelry items, uncut gems, jewelry findings, and that kind of material. But my most favorite gem and mineral show is the Gilsum Rock Swap, which is held the last Saturday in June every year since about 1964, I guess was the first one. And it's an outdoor 2-day show up at the ball field in Gilsum, New Hampshire. And it features maybe 4 dozen mineral dealers and also some tent displays by local clubs. And it is just a great time, particularly if you want to talk with local collectors and see what they're finding. It's a great spot to bring the family. I would say that unfortunately, the last 2 years, due to the COVID thing, it was not held. I had hopes that it was going to go this year, but they pulled the plug on it kind of about 4 to 6 weeks ahead of its scheduled time. I'm holding me out hope for next year. I really missed this event. And the Gilsum Swats is, as I said, it's a great place to bring the family. Many of the dealers will have boxes full of giveaway material by their tables that family members can kind of dig through and just pick out what they want, and it's a nice activity. A word on a couple of mineral museums in New Hampshire. One is the Woodmew Museum in Dover, New Hampshire, and it has 2 rooms devoted to the display of mineral specimens. There's not a lot of New Hampshire content here, but certainly many dozens of New Hampshire specimens, but it's more typically a worldwide collection, but a good opportunity to close by to see a nicely presented display of minerals. And of course, back to giving a plug to the McAuliffe-Shepard Discovery Center. This is my interactive display of New Hampshire minerals in the display case and the touchscreen monitor here. And I find that this is a great way to share, particularly the micro-sized minerals, as each specimen is illuminated in the physical display. It's lit up on the touchscreen monitor, and you can kind of drive it around and look at the different species that you'd like to see. There are certainly a lot of minerals in New Hampshire that occur in bigger specimens than what are in the display, but I wanted to get an example of as many species from New Hampshire as I could. So that kind of limited me to 1 to 1.5 inch size specimens for each species. But it did provide me a method to illustrate some of the really tiny crystals, such as this 6/10 millimeter xenotime crystal here on the right side of the photo. I'm running a bit long here. Okay, mineral identification. What is my specimen? You can look at the physical properties, which I kind of enumerated before, the hardness, the color, the luster, solubility, magnetic properties, fluorescent properties. You can understand the environment it came from. That's always quite helpful. And but it's good to consult other knowledgeable collectors, and that's where attending a club meeting can really be helpful. And as I noted, the websites, web searches, particularly you can visit the different localities which are on those websites and look at the different specimens that were found there and try to correlate what you have in your hand with one or more of the photos on the web. And finally, you can invest in getting an actual chemical or X-ray analysis of your specimen. Now, the periodic table of elements here, this is sort of Mother Nature's building block set, Lego set, if you will, for building minerals. And minerals are combinations of these different elements in different ratios. And that's what, in part, which goes to making each mineral unique. So part of the solving the question of what mineral do I have, it is most helpful to have a determination of what the chemistry is, what elements are present. The Microminers of New England sponsor a program where we do mineral analysis using the Boston College Energy Dispersive Spectrometer, which you see here. It's a nitrogen cooled detector, and it is very good at determining the elemental content and ratios of the elements in very tiny size grains of mineral specimens. We can determine the chemistry on sub-millimeter size grain samples, which is very important if you're a micromineral collector. Here's an example of what such a spectrum would look like. And from this, we can see these peaks in the spectral response indicate that the elements present in this rather colorful crystal over here are the elements potassium, manganese, and oxygen. And from this, and looking at the ratios as determined by the atomic percents that are tabulated below here, I could confirm that this mineral here is the mineral triploidite. Whoa, what's going on here? I'd like to get this back to normal size. Sometimes unintended things happen. Oh, there we go. Of course, now I'm going to finish up my talk by showing a bunch of somewhat eye candy mineral photos, and maybe a quick word on how I do this. And there's a couple of my photo setups here for photographing the very small. And I use a Canon SL3 camera here with a macro lens and then a microscope objective lens on the end of that for very high magnification. And on the right side is another alternate setup where I have a stereo microscope that is also fitted with an extra port to adapt to a camera to take photos through the microscope. So now we just kind of finish up with some photos that I think are some of the more attractive examples. These are all from New Hampshire. This is a photo of the mineral acanthite, very small, 0.7 of a millimeter. Think back to the salt crystals. And this one is from that lead silver mine, the Mascot mine in Gorham. A rather attractive, very feathery development crystal. This is a silver sulfide mineral. Here we have the mineral anatase, titanium dioxide, a deep glassy blue steep bipyramid sitting amongst a bunch of quartz crystals. This one from the Pike Quarry in Hooksett. This is an example of something that was collected from a club-sponsored field trip, because the Pike Quarry in Hooksett is an active quarry, has been for a couple of decades, but through contacts with the mine owner and our club, we were able to gain access for a field trip. This mineral here, boronite, is an example of a mineral, a phosphate mineral from the Palermo mine, which I showed some photos of earlier on. About a 5 millimeter point of view, kind of some kind of stellate sprays of a green bladed mineral. This bright yellow spray balls of the mineral coxonite, another phosphate mineral. Again, from Palermo, as I mentioned, Palermo is one of the most, or the most species prolific locality in New Hampshire. So lots of really excellent minerals have been found at that mine. This is a mineral cerussite. This came from a construction site on Johnson Road in Bow, New Hampshire. An example, this was a big warehouse building was being put in, and during the blasting for the site, it exposed a quartz sulfide vein. Cerussite is a lead mineral, lead carbonate. And the thing it is with these types of collecting opportunities, they can be very brief. There can be some good minerals briefly exposed, but they're gone way too soon. It's a mineral eleanorite, a kind of a lateral fan of yellow crystal blades. This one from that Chickering mine in Walpole, the Boy Scout locality. Now this is the mineral eucryptite from the Parker Mountain mine. And as you look at it here, it's not particularly exciting or remarkable. Might be easily mistaken on the dump, particularly if it was kind of dirty, as just another piece of feldspar. However, when one illuminates it with a shortwave ultraviolet light, it is fluorescent, a nice bright red purple here, or pink purple, I guess. And that is a distinct characteristic of this mineral eucryptite. And I guess it would also state here that New Hampshire has probably about a dozen minerals that are quite attractive as fluorescent minerals. And there are mineral collectors who just specialize in fluorescent minerals. There are, in the hobby, there are quite a few areas to specialize in, and fluorescent mineral collecting is one of them. This is the mineral graphite, graphite is just pure carbon. It's interesting that I didn't mention previously, but graphite was actively mined in about a dozen or more New Hampshire mines. And this is a 6 centimeter graphite nodule, kind of resting in some matrix. And of course, graphite, particularly in the 1800s to maybe 1900s, particularly in New Hampshire, was a valuable commodity because it was the source of lead for pencils. And it was also used as a refractory mineral in the casting industry. And some of actually the largest excavation mines in New Hampshire, I'm thinking particularly the Osgood mine in Nelson, are just huge cavernous mines. Amazing amount of rock was removed in the pursuit of the extraction of graphite. Back to the tiny again. This is a 1.5 millimeter field of view here on another attractive phosphate species from the Palermo mine. This is the mineral laueite, and this is the typical habit for that species. Pyrite, back to a little bit bigger specimen here. Pyrite is a common mineral in New Hampshire, but there aren't many localities where it forms these nice, sharp, golden, brassy crystals, such as this occurrence in Lyman. The matrix here is a slate. This is an outstanding specimen of amethyst, which is a variety of quartz. This was collected by Carlton Holt probably a couple of decades ago from another opportunistic find from some blasting for a road cut in Randolph, New Hampshire. This may be the best amethyst specimen that's been recovered from New Hampshire. It's 8 centimeters high. It's just gorgeous. And I didn't really have a chance to make a great photo of this. It was an opportunistic snapshot. Back to the tiny again. This is the mineral sky blue, robin's egg blue mineral Schulenbergite, which is a copper zinc mineral, quite small, but really quite attractive. Here we have a sphalerite crystal in matrix, kind of yellow orange crystal, nice form. And this came from a road cut for the 101, 101A interchange in Amherst. I love this photo. This is a kind of great composition. That we have a kind of a pink ball of the mineral stringite here with a cross-coupled pair of rockbridgeite crystals. This came from the Fletcher mine in Groton. They just almost, the pink ball looks like, a candy drop you could probably just munch on, but quite small. Back to topaz again. This is another one of Carlton Holt's find, again from that government pit, but this is might arguably be one of the best from New Hampshire. It's about an inch tall, nice honey colored gem quality topaz, kind of in a bed of kaolinite. Here we have a tablet of the mineral torbanite, which is a copper uranium phosphate from the Palermo mine again, kind of strikingly attractive on the dark rockbridgeite background. Here we have a small bladed cluster of vivianite, another phosphate mineral from Palermo, and very small, kind of, this is approaching the limit of what I can do with my photographic equipment, but a nice sharp cluster of the species. Notice I'm going through this alphabetically. This is a Whitlockite crystal, which is kind of the clear to milky colored crystal, and it is impaled on top of a spear of the mineral siderite. So kind of an interesting combo specimen. It's kind of like just kind of screams, take a photograph of me, and it's kind of a neat combination example. Here we have the mineral xenotime. This came from the North Sugarloaf quartz locality in Bethlehem, New Hampshire. It's quite tiny, but nice sharp bipyramid crystal. And that concludes my slideshow of specimens from my collection. So I think we can open this up to questions if Mirka would like to enable that or facilitate that.
Yeah, thank you so much, Tom. That was beautiful. I have to say that the colors alone were just amazing. So we have time for a few questions. So if anybody has something that they want to put in the chat box, or if you want to raise your hand or use the Q&A, please feel free to use any of those methods. I do have a question to start us off. I was thinking about that picture you showed of the outcrop, and you said it was like near the Home Depot, and I could see that it looked like there was a Dunkin' Donuts sign there too, of the pegmatite, and then you kept mentioning road cuts and blasting for rock, and I thought about how often we drive past rocky outcrops just because of where we are and where we live. So I guess my question is, are we going past these things, I mean, these outcrops and these crystals and these minerals all the time? Is that what we're passing when we're driving on the interstate, or when we're, going into falling rock zones, or seeing these rocky outcrops on the side of the road?
in general, finding a good mineral specimen requires a certain amount of quite a bit of luck, particularly if it's a new road cut, a new construction site, and so on. I think probably for every maybe 10 of those kind of things that I investigate, maybe if I find something I want to add to my collection from one of them, or maybe two, I'm doing pretty well. And of course, being a species collector, I will probably collect things that others might leave behind. My recommendation would be for at least those starting out to go to sites that have produced specimens in the past, and to kind of get started and not get discouraged too quick.
Okay. So we have a few questions and comments in the chat box. So so the first one comes from Emily, who said, mascot mine is sealed to protect the bats that hibernate there. It's also very dangerous inside. Are you just exploring the tailings there?
Yes. Yeah, the mascot mine was a tunnel mine. And some time ago, probably more than a decade, they put a very substantial steel grating in front of the mine entrance. And they did this for two reasons. One, to keep people out because it's dangerous in there. And secondly, they wanted to continue to provide access for bats. So the bats get to go in and out freely, but the collecting community is prohibited. But yeah, the specimens from the mascot mine are collected from the mine dump. Most of the productive collecting that I think has been done is from the bottom of the tailing pile, quite close to the pond, which you may have seen in the old photographs.
Okay. And then we have another question from Megan, who says, my son, 8, would like to know what gives minerals their different colors.
What gives minerals their different color? Boy, well, in some cases, there are small impurities that are in addition to the main composition of the mineral. A good example of that would be quartz, and when it's purple, it's amethyst, and when it's yellow, it's citrine, and sometimes it gets a little green. The dark smoky color that you see in some of the quartz crystals I showed was imparted from radiation. When these mafic cavities were deeply buried, there was a lot of radiation present deep in the earth, and the radiation actually caused, I guess, micro breaks in the crystalline structure, which gave the crystal the dark color. Now, as far as the amethyst and citrine, there are what collectors refer to as chromophores, and I think it's small additions of example of iron in the quartz, which is silicon dioxide. Just a little bit of quartz also interspersed in the crystalline structure will give it a purple color. Again, you take the mineral beryl, which has a gem variety emerald, which is the bright green, very desirable variety of beryl, and the green color is imparted by a small amount, usually, of chromium within the beryllium matrix, and it gives it that intense green color. So, in summary, I guess it's little tiny bits of other elemental impurities in varying amounts, which are responsible for imparting the different colors to minerals. In general, I mean, you'll find that like your copper family of minerals of which I showed several examples here, the malachite, the wolfenite, and paramorphite, and the torbernite, which are quite colorful. Copper, when it alters from its native copper state into these secondary minerals, usually through meteoric waters and so on, as the copper is enabled to migrate through the country rock, it forms usually bright blue and green minerals. So copper is usually responsible for a lot of the green and blue colorations, like including the azurite and linerite examples I showed.
Okay, thank you. So we have another question from Ian, who said, were there commercial, industrial uses for the crystals, or were they mostly for jewelry?
I mean, for usually for jewelry, the crystal has to be nice and clear and transparent, or what you might call Jenny. Of course, that nice, pure, unfractured, uncloudy crystal is a lot less common than the ones that are kind of cloudy or milky. So those of course are the most desirable, both by the mineral collecting community, because they like the beauty and the aesthetics of a nice, clear, pure crystal, and they're also very desirable from the lapidary community. Now, the lapidary community will also make a cabochon, which is kind of usually typically an oval-shaped gem mount of opaque minerals, and usually these are selected because of the color or pattern in the mineral itself.
Mm-hmm. Excellent, thank you. So if anyone has any other questions, please either raise your hand or put them in the chat or the Q&A. And if you're like me and you're the kind of person who thinks later on about a question that you wish you had asked, tomorrow you'll all be getting an email from me thanking you, asking for any comments, suggestions, but it will have my email address, so that if you have any questions for Tom, you can send them to me and I will pass them along to him. So we have one more question. It looks like, have you ever found fossils?
Fossils are really very rare in New Hampshire. Much more common like over in Vermont, New York, because the predominance of bedrock in New Hampshire is igneous and granite and metamorphic. That's not an environment that is particularly good to preserving fossils. I believe I have heard of, there are a few fossil localities in New Hampshire. These are rather closely guarded secrets, because I guess they would rather not have collectors in there running off with the specimens. I think the Department of Environmental Sciences in Concord keeps an eye on these particular localities. And as I say, I don't think there's more than a handful of them, and I don't think the fossils are particularly spectacular by worldwide fossil standards.
Mm-hmm. I remember looking for an activity with students, looking at the fossil record or lack thereof in New Hampshire, and then comparing it with other places. And I think I saw the comment that if you're looking for New Hampshire's fossils, you should be looking in Long Island Sound.
Yeah,
because so much has simply been washed away.
Yeah, we took a heavy hit on the top 1,000 feet or so with a couple of passes of glaciers, which didn't do quite as big a job on Rhode Island.
Yep. Okay, well, thank you so much, Tom. This was fantastic. I know there were comments as well in the chat box about everyone enjoying and being excited by this. So as I said, if you think of anything else, please send me your questions and I'm happy to pass them along to him. Please come by the Discovery Center if you want to see some of his collection. He showed you what it looks like, and it is so neat to be able to see it'll light up on the panel. This is the specimen, and then it shows you the information on the screen. So you really get a sense of that's what that looks like up close. And Tom, thank you so much. This was fantastic. Really appreciate it. So what I'm going to do is I'm going to end the meeting. I want to thank you all for joining us. I hope you have a wonderful first weekend of October, and we hope to see you again soon. Good night.
Good night.